This is the RStudio user interface. It uses R programming language to manipulate data. Simply put, it's just another tool used for data analysis, such as Excel, for example. What I would like you to do first is click on this white sheet and create a new R script. Now the screen basically consists of 4 different sections. The most important is the bottom left, the console. This is where you run the R code and where the magic happens, let's say. For example, we can perform simple calculations here. Let's type 2 plus 2 and hit enter. It runs the code and returns 4. Then the top left is the so-called source editor, a place used for scripting or writing your code. You can think of this as a text box. Any script you write here can be saved and ran at another time. It will become more clear once we begin to use it in a few seconds. Then on the top right, we have the environment/history/connections tab, which is not that important for a start. Basically, the environment tells you which objects you have stored. We will see how this works later on. And finally, in the bottom right section, we have first a file browser for your computer, then the plots section, where you can see any plots you generate, then packages. It's loading. This shows you the packages you have installed in your library, and then the help tab, which if you look for any help with any functions or packages, this shows you the description of them. And the last one is not that important. So, as I've said before, the console is the most important part, and the most important section, and it is what R basically is. You may look at it as a calculator. As I have shown before, here we can do simple calculations with mathematical operators. For example, if we type 5 minus 2 and hit enter, it will return 3. What you see in blue is your command, and what you see in black is what gets returned. We could write the same thing without spaces, but generally it's considered better to use spaces between operators when writing any code, just to make it more readable. You can multiply, divide, let's say set to the power of, and perform other operations, and you can also combine these in a way as you would using a calculator. Let's say 5 plus 10 divided by 2 to the power of 3. As you write and run the code, the previous commands move up. If you want to use a previous command or make some change to it and run it again, you can access it using the up key or down after. It will scroll through the most recent commands you've made, and then you can just change what you like and run it again. So let's change the last one, let's change the last number, and we get a new value. A better way to write the code and test which bits of code work and decide which ones you want to delete or keep for later is using the script. Similarly as in the console, here you can write any code. For example, 5 minus 2. But when I hit enter here, it doesn't run anything, it only takes me to the next row. In this part, I have to press Ctrl and Enter so that the line gets passed to the console and runs it in the same way as before. So we can think of a script as a better way of writing a code you want to keep editing or perfecting as you go along. So from now on we will write and run the code from here using Ctrl and Enter. If there are any bits of script you do not want to run and just wish to have them as a side note to remind you what you did, you have to begin the line with a hash. And you can write anything. It's there purely for your own use. For example, if I write my first R code and try to run it by hitting Control and Enter, R won't be able to see it, so it doesn't do anything. So this is here only for your understanding. Putting hash in front comments out the line, and in this version it's shown in light green. So from now on I will use this to write the titles for things we will cover as we go along. So let's begin with objects. Everything in R is an object or can be saved as an object. These objects can be of different types. We have three main types. So we have numeric, which are basically numbers. We have character, any text, always written with quotation marks. And then we have logical values, either true or false. So let's try and assign different types of data to objects, which we will name A, B, and C. Let's say A is 3.5 and run it. Then B is, let's choose a string Monday and run it. And C is a value of true. Any object you assign a value to will also be shown in the Environment tab, as you might have already noticed. You can see that in RStudio, different types of data are shown in different colors. So numeric in dark blue, character in dark green, and logical in light blue. If we now type A and hit Control and Enter, R returns us a value of 3.5, which we assigned to A. Whenever we assign a new value to a certain object, it replaces the last one. So if I type A equals 10 now and run it, A was replaced with a 10. The previous value of 3.5 was replaced with a 10. I have to mention here also that R is case sensitive. So there's a difference if we use lowercase or uppercase letters. What I mean by this is that if I write, for example, my object equals 5 and run it, and then my object using the lowercase letters equals 5 and run it, it will create two objects of the same value. It won't replace the previous one. For example, if I now change the value of the second one and run it, it will only change the second object with the lowercase letters. There are also some rules in naming the objects. For example, the name cannot start with a number. So, for example, 1 object equals 2. It returns an error. You're also not allowed to use special characters. But what you can do is you can put a number at the end, or you can use dots, let's say 8, and underscores. To organize data, we can store it in different data structures. The most commonly used ones are vector, matrix, and data frame. A vector can store one row or column of only one type of data, so only numeric or only character. A matrix can store multiple rows and multiple columns of one type of data, whereas data frame can store multiple rows and multiple columns of different types of data. But for the purpose of this course, you don't really need to know how to create matrices or data frames, as you will most likely read in the data you have prepared in Excel or another program. But if you're interested, there are many other tutorials or resources on this online, as R is an open source language and it has a large community of users. Also, if you Google anything you would like to know how to do, an answer will usually come up. Now, let's try and create a vector. We create a vector using C, which stands for combine. Let's name it vector V. And let's create a vector with values from 1 to 7. And run it. We can see that now we have a numerical vector with the values from 1 to 7. We can create it using another way. We can also write this. And it gives the same, or let's name it differently. It gives the same values. You are probably a bit confused what this C with brackets is doing here. This is actually a function we use to create a vector. A function is a set of statements organized together to perform a specific task. So when we call a function, it does something. It always has a name with 2 brackets where you can put the values or arguments as they're called. And we will use functions later in the course to calculate drought indices, for example. R has a large number of built-in functions, and the user can also create their own. Some basic functions in R are mean, sum, max, square root, etc. You can check what each function does using the Help tab on the bottom right, we've seen before. So you can write mean here, or write question mark and the name of the function and run it, and it will return what you're looking for. Or let's check what square root function does. It computes the principal square root of x, what we expected. So if we want to apply this function, let's apply it to a vector we previously created. Let's write mean of the vector v and run it. It returns 4, which is the mean of these values here. Basically what the help section tells you is what the function does, what input is necessary, and what's the output of it. Some other useful functions are, for example, class, which tells you what type of data we're dealing with. Oh, and also whenever you write the name of the function, if it exists in our environment already, it will offer you an explanation of what it does. So let's check the class of one of the objects we created before. Let's say A. The class of A is, as we expected, numeric, and let's check the class of C is logical, an object type logical. Other useful functions, for example, are length. We can check the length of the vector 7. And similarly for matrices and data frames, we can use dimensions, dim function, to check for dimensions, so how many rows and columns a matrix or a data frame has. So if you want to do data analysis with R, you first need data. You can read in your data using functions. For example, to read in a CSV file, you use function read CSV. Let's see what it does. Reads a file in table format and creates a data frame from it, as we expected. To read in an XLSX file, which is an Excel file, we can try and see if there's a function read XLSX. However, this function doesn't appear to exist in our library. So we now have to install a package called XLSX. We do this by using a function install packages and writing down the name of the package and run it. This is now being loaded, and yeah, it's done. So this package is now installed in your library on your computer, but to be able to use it, we also have to, let's say, call it from the library. We do this by typing library and the name of the package. In this package, there's a function to read XLSX data, which is simply called read XLSX. We can see what it does. It reads the contents of a worksheet into an R data frame. I have prepared an XLSX file with with daily values of precipitation. It's also available for you to download. It looks like this, with one column for dates and one column for precipitation in millimeters. And we have 4 different sheets for different stations, different meteorological stations in Slovenia. I would now like to read this data into R. To be able to read in the data, I need a so-called path or location of this file. In Windows, I can get this by clicking on the top of the folder browser and just copy and paste the location into the function. So read xlsx, and I always have to put the path or the location in quotation marks. And yeah, in this case I have to change the backslashes into forward slashes. It's just the way R reads it. But here I only have the actual folder, not the file itself. If I hit the tab button at the end, oh sorry, I have to add another forward slash. If I hit the tab button, it offers me everything that this folder contains. So here I can find my daily precipitation file, and let's run this. It returns an error. It says please provide a sheet name or a sheet index, and if I check how this function works, I can see that I can either put in the sheet index as a number or a sheet name. Let's go back at our file. Let's decide for this sheet called Maribor, and just add sheet name equals it's now reading in the data. It's a lot of data, so it might take some time. Okay, so here it's trying to show me all the data, but because there's so much data, it stops at a certain point. So best way to avoid this is by just assigning this data table to a certain object. Let's name it my data. It's now reading in the file and storing it as my data. Okay. Another useful function now to check the structure of your data without getting this long list of all data is a head function. So if I type head my data and run it, it will return the first 6 rows of your data, including the column names. It's easy to check the structure of your data this way. As mentioned before, you can also check the dimensions of this data table. For example, dim my data and run it. It shows you that there are 10,957 rows and 2 columns, one for each of these values. We can also check what type of data my data is using class, similarly as before. Class my, and it tells me it's a data frame as expected. We can access data from a particular column of this data frame using the $sign after the name of the object. For example, if I write my data, $sign, it offers me the names of the columns. So if I select precipitation by hitting enter and then run it, it will only return the values of the precipitation without the dates. We can analyze this data using functions such as max. What does max do? It returns the maxima of the input values. So if we try max of my data and run it, max my data precipitation, it gives you the maximum daily precipitation of the period we're interested in. Why it didn't work before, why it returned an error, is because I wanted to use max for the whole data frame, and obviously you can have a maximum date value, not in this sense. If we now want to check the class of each column, let's say my data, precipitation, it's numeric, but if I check the first column, the date, it's a date type of object, which is a sort of a character object, but for storing calendar dates. You can play around with this data and test it using different functions a bit, but for today I think this is quite a lot to take in, especially in this short amount of time, but I promise it will make more sense when we begin to use real data tomorrow.